All right, guys, let's start. Um, Cambridge International AS Level Examination, Chemistry Paper 1, Multiple Choice, May, June 2023, Variance 11. The duration of this paper is 1 hour, 15 minutes. We have 14 questions and we need to attempt all of them. All right. The total mark for this paper is 40. Most importantly, let's start with question number 1, see what we have. Element X has 6 more protons than element Y. Okay, and that's a general sort of situation because they haven't given any period number or group number. All right, they haven't given any sort of information. So which statement must be correct? Atoms of element Y are smaller than atoms of element X. Let's take an example here. We have done period 3 in the class. Okay. And in period 3, we have done atomic radius. So let's suppose if sodium has an atomic number of 11, an examiner is saying it has 6 more protons. So when you add 6, it's going to be 17. That is chlorine, right? So we know that atomic radius decreases across the period. So let's suppose if sodium has Y, then chlorine becomes X after 6 more protons, right? So A is going to be the incorrect option because chlorine has a smaller atomic radius than sodium, whereas it is saying atoms of element Y are smaller than atoms of element X. So element X is smaller than element Y, which means this statement is absolutely incorrect. Let's talk about the B option. Element X has full shell of electrons. Element X has full shell of electrons. Element X has full shell of electrons. So for B, let me give you an example here. Let's suppose hydrogen. Hydrogen is Y. It has an atomic number of 1. When you add 6 in it, you will get nitrogen. So nitrogen, let's suppose, is X, right? Let me configure this. The configuration is 1s1. Over here, the configuration is 1s2, 2s2, 2p6. All right, now in this scenario, nitrogen has 1 full shell as compared to hydrogen, right? So element X has 1 full shell as compared to element Y. Seems like it's a right option. Okay, because it has full shell of electrons. So this must be the full shell, right? So this statement is going to be right for every element. Element X and element Y are in the same group, not necessarily. Like sodium belongs to group 1 and chlorine belongs to group 17. So absolutely incorrect. Next is element X and element Y are in the same period. Not necessarily, because if you compare nitrogen and aluminum, let's suppose aluminum is X, nitrogen is Y. So nitrogen has an atomic number of 7. If you add 6 proton, it's going to be 13, which is aluminum. So nitrogen belongs to period 2, whereas aluminum belongs to period 3. So this is not the correct statement. So this must be incorrect. Okay. So right answer is going to be B. Question number 2. Which statement explains why calcium has a higher melting point than barium? Calcium has a higher melting point than barium. We know that down the group, atomic radius increases. And if atomic radius increases, obviously nucleus, in fact, metallic bond becomes weaker. Which means electrostatic attraction between positively charged ion so electrostatic attraction is going to be weaker. On the basis of this, let's read the statement. One more thing. Since calcium and barium both are found in the same group of the periodic table, so they have same number of valence electrons as well. Okay, let's talk about options. Let's talk about option A. Calcium cations are smaller than barium cations. That's true because down the group radius increases, so calcium is smaller than barium. So calcium ion is also smaller than barium ions. That's right. Next read करते हैं. And have a stronger attraction to the delocalized electrons. That means calcium has a smaller size, so it has a stronger electrostatic attraction. That statement is right as well. So A is going to be the right answer, but let's talk about the other options as well. The structure of calcium is partially giant molecular. No, calcium is metal. It has giant metallic bonding, which means B is incorrect. Let's talk about C. There are more delocalized electrons. Cannot be more delocalized electrons because they have same number of valence electrons as they are found in the same group of the periodic table. So it's incorrect again. Let's talk about option D. There is a greater repulsion between barium atoms as they have more complete electron shell than calcium. There is no repulsion exists between barium atoms because there is an electrostatic attraction exists between positively charged ion and a sea of electron. All right. So again, this is incorrect. Right answer is A. Let's talk about question number 3. 3 statements about potassium and chlorine and their ions are listed. The atomic radius of potassium atom is greater than atomic radius of chlorine atom. That might be the true because potassium has an atomic number of 19. So according to O-level chemistry, it has 2, 8, 8, and 1. That means it has 4 shells. Whereas chlorine has an atomic number of 17. So if we configure it, so it's going to be 287. So it has 3 shells. It has 4 shells, which means it has bigger radius than this one. So first is going to be the right statement. Next, the first ionization energy of potassium is greater than first ionization of chlorine. Since potassium has more shells, so it has weak nucleus to electron attraction. If it has weak nucleus to electron attraction, obviously removal of electron from potassium becomes easier. If removal of electron from potassium becomes easier, obviously its ionization energy must be lower. So this statement seems like incorrect. Next. So technically, what I'm saying is ionization energy should be lower instead of greater. Okay. The ionic radius of potassium ion is greater than the ionic radius of chloride ion. Uh, mm, mm, mm. Now, potassium is a metal and metal forms cations. So potassium has +1 charge because it belongs to group 1 of the periodic table. Chloride has -1 charge. I've told you in the class that the size of an ion is always greater than that of the neutral element, and the size of cation is always smaller than that of the neutral element. The size of cation is smaller because of the strong proton to electron attraction, whereas the size of an ion is greater because of the electronic repulsion, right? So in this scenario, in this comparison, obviously chloride has a bigger radius than potassium ions because of repulsion. So third statement is also incorrect because the ionic radius of potassium ion is not greater, it must be smaller. All right, so seems like A is going to be the right answer because it's asking which statement is correct. Question number 4. For which equilibrium do both of the equilibrium constant Kc and Kp have no units? Let's talk about option A. Let me write the expression. Kc equals to concentration of product, which is Hi. Since we have 2 moles, so it needs to be here. We have 2 moles, so number of moles has to be in the power over the concentration of reactant. So it's H2 and I2. Let me write the Kp expression. This is partial pressure of Hi power square over partial pressure of hydrogen and partial pressure of iodine. So concentration unit are cancel out with each other. Similarly, partial pressure units is also cancel out with each other, which means Kc and Kp in this scenario has no unit, which is why A is going to be the right answer. Obviously, option B is incorrect, C is incorrect, D is incorrect because they have different number of moles on both the side, both on reactant and product side, which means this must be some sort of unit, this must be some sort of unit, it has some sort of unit, right? But A has no unit because the units are cancelling out with each other because of the same number of moles on both the side. Okay. Next is question number 5. Calcium carbide CaCO2 reacts with water. As shown, the data below the equation shows in kilojoules per mole the standard enthalpy change of formation of compounds given. The standard enthalpy change of formation of compound is given, right? Formation data is given. If formation data is given, we can find the enthalpy change of reaction for this equation. So let me write the equation again. It's calcium carbide CaCO2 plus water, calcium oxide, and ethine, which is C2H2. We need to find out the enthalpy change of reaction for this equation. Since formation data is given, so we need to start the Hausdorff cycle from the constituent elements under standard condition. Okay. Place a clockwise arrow in it. Calcium carbide has -60, water has -286. Calcium oxide is -635, and C2H2 is +228. Now, this arrow and this arrow is basically follow the clockwise direction, which means both these 3 values taken into positive, while these 2 are going backward. I'm in opposite in direction, which means we'll consider them as negative. So this must be positive value plus -60 plus -286. So these 3 values becomes positive, these 2 values becomes negative, minus -635 minus +228 equals to 0. Why are we equating with the 0? So that we can find the value of delta HR. So delta HR is going to be -61 kilojoules per mole. So right answer is going to be B. In the sodium chloride lattice, the number of chloride ions that surrounds each sodium ion is called the coordination number of sodium ion. What are the coordination numbers of the sodium ion and chloride ion in the sodium chloride lattice? Well, I've told you in ionic bonding that each sodium ion can hold 6 chloride ions And similarly, 6 chloride ions can hold 6 sodium ions. So if we want to write this is sodium ion, and this is chloride ion. So if it is sodium, it must be connected with chloride ions. So we have 6 chloride ions around sodium. Similarly, we have 6 sodium ions around chloride. So that's 6, 6, 6. So right answer is going to be obviously C. I hope it makes sense to you. That's an O-level chemistry. You have done this entire information in O-levels as well. That in the crystal lattice of sodium chloride, each sodium ion can hold 6 fluoride ion and vice versa. That was the statement usually given in O-levels, right? Now, question number 7, histidine is an amino acid. Amino acid is a class of compound which contain both amino and carboxylic group. So this is amino group and this is carboxylic group, which means this compound belongs to amino acid family. All right. Now we have three different situations. We have 1 here, we have 2 here, we have 3 here. An examiner wanted to ask the bond angles of each situation, right? So that's an easy task. We have done this in class so many times. A carbon has 2 single bond and 1 double bond. So in order to get the hybridization geometry and angle, take this double bond as a single bond. So around carbon, we have 3 single bond and a 0 lone pair because carbon belongs to group 14, and so it has 4 valence electrons, and all these 4 electrons are involved in the bonding, as you can see in this diagram, right? So in order to determine the hybridization, double bond considered as a single bond. So we have 3 single bond around this carbon atom, and there is no lone pair, so you will get total 3. Draw 3 lines. The first line always represents s orbital, the remaining 2 line represents p orbital. So whenever we have 3 single bond and a 0 lone pair with sp2 hybridization, obviously angle is going to be 120 degree. So 120 degree, the B, C, or D might be the right answer. Let's talk about nitrogen. Nitrogen belongs to group 15, so it has 5 valence electrons. Let's distribute those 5 electrons. 1, 2, 3, 4, 5. Now, around nitrogen atom, we have 3 single bond, or we have 3 bond pairs. We have 1 lone pair. So in total, we'll get 4. Draw 4 lines. And that's a shortcut technique. The first one is s orbital, the remaining 3 is p orbital. So the hybridization is going to be sp3. So whenever you have 3 single bond and a 1 lone pair with sp3 hybridization, geometry is trigonal pyramidal, and the angle is going to be 107 degree. So 107 degrees here, 107 degrees here. Let's talk about the last one. That is this one. Now carbon belongs to group 14, so it has 4 valence electrons. Let's distribute 4 valence electrons of carbon. 1, 2, 3, 4. Now around carbon atom, we have 4 single bond or 4 bond pair, whereas 0 lone pair. So you will get 4. Draw 4 lines. So first line represents s orbital. Remaining 3 lines represents p orbital. So hybridization is going to be sp3. Whenever we have 4 single bond and a 0 lone pair with sp3 hybridization, angle is going to be 109.5 degree. So 109.5, 109.5. I think B is going to be the right answer. Okay. Question number 8. The contact process takes place at a pressure between 100,000 pascals and 200,000 pascals, right? So basically, this must be the lower pressure. This must be the higher pressure. All right. And this 1000 kilopascal, it is 100 pascal, right? Kilopascal, right? And this is 200 kilopascal. And remember, 1 atmosphere is equals to 101 kilopascal under standard condition. Okay. A catalyst is used. Catalyst increases the rate of reaction. And how it increases the rate of reaction? By increasing the effective collision in a unit time. Or by increasing the collision frequency, you can say that which statement is correct? V2O5 catalyst is added to increase the equilibrium yield. Catalyst never increases the equilibrium yield. In fact, it increases the equilibrium rate. That means it increases the rate of forward as well as the increases the rate of backward, so that equilibrium attains more quickly. Okay, so this must be the incorrect option, because catalyst never increases the equilibrium yield. It always increases the equilibrium rate. Next is changes in pressure have no effect on the position of equilibrium. Well, that's also incorrect, because if we talk about contact process, we have 3 moles on the reactant side, and we have 2 moles on the product side. So as the number of moles on both the sides are different, which means if we change the pressure, equilibrium position also changes, right? The position equilibrium changes when we change the pressure. Either it moves in the forward direction or either it moves in the backward direction, depending if we are increasing or decreasing the pressure. So that means changes in pressure has an effect on the position of equilibrium. So has an effect. All right. Now the next is the equilibrium yield of the reaction is very high under the conditions used. Obviously, we are increasing the pressure from 100 to 200. So if we increase the pressure, equilibrium favors towards right hand side, sulfur dioxide yield increases. So that must be the right answer. Let's talk about D. An iron catalyst is added to increase the rate of reaction, while V2O5 is used as a catalyst in contact process. Iron is used in the Haber's process, which means D is in correct option. Okay, that's guys sulfur dioxide. Okay, let's move on to the question number 9. Bromine reacts with aqueous sodium hydroxide at 25 degrees Celsius. Okay, reaction 1. Bromine, when reacting with NaOH under cold condition, it is going to be converted into sodium bromide, sodium bromate 1, and water. Now, sodium bromate 1 formed is unstable at 25 degrees Celsius and reacts further. So when sodium bromate 1 reacts further, it will turn to sodium bromide and sodium bromate 5. So which reactions are disproportionation reactions? Disproportionation reactions, we have discussed a lot, are those in which an element simultaneously oxidized and reduced in a similar reaction. So when 2 different oxidation states exist in a similar reaction for a particular element, then this reaction is going to be the disproportionation reaction. So let's talk about how reaction 1 is basically the disproportionation reaction. Well, in reaction 1, bromine is converting to bromide ions, which means bromine changes its oxidation state from 0 to -1. Whereas in the same reaction, bromine converting into NaBrO or NaOBr. It doesn't make any difference, by the way. So in this scenario, bromine changes its oxidation state from 0 to +1. And I hope you should understand how to calculate NaOBr. How to calculate the oxidation state of bromine in this scenario. The bromine, let's suppose, is X. Sodium has a charge of +1. Oxygen belongs to group 16, so it has a charge of -2. Since the compound is neutral, molecule is neutral, has no charge, which is Y equals to 0, then X equals to +1. So bromine in the first reaction is reduced as well as oxidized, which means the first reaction is disproportionation reaction. Now in the second reaction, let's talk about what's going on here. In this scenario, bromine has an oxidation state of +1. In this, bromine has an oxidation state of -1. In this, bromine has an oxidation state of +5. Let me give you the calculation area of sodium bromate 5. Let's suppose bromine is X, sodium has a charge of +1, oxygen has a charge of -2. We have 3 atoms. Compound is neutral, has no charge, equals to 0, then it's equals to +5. Again, bromine is reduced and simultaneously oxidized, which means reaction 1 and reaction 2 both are disproportionation reaction, which means A is going to be the right answer. And why both disproportionation reaction? Because bromine is reduced in this conversion, simultaneously bromine is oxidized in this conversion. Same here, bromine is getting reduced, bromine is getting oxidized. So bromine technically exists in two different oxidation states in the same reaction, which is why both are disproportionation reaction. Okay. Next, which statement is correct? The relative molecular mass. Molecular mass of a molecule is 16. So oxygen is a molecule and it has a mass of 32, not 16, which means option D is incorrect. All right. The relative isotopic mass of magnesium is 24.3. Relative isotopic mass is not the average mass, right? So it must be 24, not 24.3. Okay, so this must be incorrect. The relative formula mass of calcium carbonate is 100.1. This seems to be the correct answer. Let me calculate. Calcium has a relative atomic mass of 40.1. Carbon is 12. Oxygen is 16 times 3. So it's going to be 100.1. So this is correct. And relative formula mass is basically calcium carbonate is an ionic compound. So ionic compound cannot exist in a molecule, which is why हम हमेशा relative formula mass use करते हैं. All right. So B seems to be the right answer. Let me discuss this one. Relative atomic mass of fluorine atom is 35.5. No, because relative atomic mass, this 35.5 shows both the isotopes of fluorine 35 and 37. They usually exist in 3:1 ratio, right? So this relative atomic mass is basically shows the two different isotopes of fluorine, whereas examiner is giving the relative atomic mass of Cl35, which is not going to be 35.5. It has to be 35 exactly. So is incorrect. Okay. Question number 11. Iodine and propanol reacts according to the following equation. If the concentration of propanol is increased, number of reactant particles increased. If number of reacting particles increase, effective collision in a unit time increases. And so rate of reaction increases. Okay. Keeping the total volume constant and the initial rate of the reaction also increases. All right. So if concentration increases, initial rate increases. So that's the different scenario. I don't know whether it's let's suppose we have two different situations here, rate and versus concentration. So rate versus concentration. So if rate increases, concentration increases, rate increases, it might be the directly proportional to each other. So graph must be like this. It's also, we can show this graph like this. Like if concentration increases, rate becomes fourfold. So sketch has to be like that, right? So these are the two possibilities. Let's see what we have in this question. What could be the reason for this reaction? Okay. Obviously, option B is incorrect because when concentration increases, particles becomes close together. Okay, particles are closer together at higher concentration, not they are moving apart. Option C is also incorrect because the particles have more energy at higher concentration. Well, concentration has nothing to do with the energy. Temperature has an effect on energy because when temperature increases, kinetic energy increases, right? So concentration has no effect on energy, right? Temperature is directly proportional to energy, not concentration. All right, now competition exists between A and D. Let me read. A greater proportion of collision are successful at a higher concentration. There are more collisions per second between particles at a higher concentration. I think this statement is going to be the right statement. Effective collision in a unit time increases. That's given in D, and D is going to be the right answer. And also, one more thing. This concentration never increases the proportion. Temperature increases the greater proportion, right? Concentration never increases the greater proportion. So proportion term is really, really important here. So concentration has no impact on proportion. But temperature does, okay? Question number 12. 4 successive ionization energies of element E are shown. Element E is in period 3 of the periodic table. In which group of the periodic table is E? We'll take the difference between these two. So it's going to be 4,000, 4,000, and 5,000. This difference is extremely small. In group of the periodic table is E, group 15. When we talk about group 15, इसका मतलब big energy gap exists between 5th and 6th. Okay. So 5th and 6th has not a big energy gap, which means B is incorrect. If let's suppose element E belongs to group 16, which means big gap or big energy gap exists between 6th and 7th. Now between 6th and 7th, again, there is no big energy gap, which means C is also incorrect. Let's talk about D. If this element E belongs to group 17, which means big energy gap exists between 7th and 8th. So 7th and 8th has no big energy gap, means element doesn't belong to group 17, and therefore if B, C, and D are incorrect, obviously A is going to be the right answer. Okay. Question number 13. Okay. Question number 13. So we have a gas is formed which behaves as an ideal gas. So it's basically PV equals to nRT. We have a mass of magnesium reacting with this much concentration in volume of HCl at this temperature under this pressure. Which volume of gas is produced measured in these conditions? So, okay, first of all, we need to find out the moles of magnesium, then we need to find out the moles of HCl, then we need to find out the limiting reactant. Once we will find out the limiting reactant, then we need to find out the moles of that particular limiting reactant, and that number of moles of that limiting reactant is going to be placed in PV equals to nRT. So once we will get the volume in meter cube, we have to convert it in dm cube. Seems like this must be a lot of calculation which I can't, cover in this such a small space. So let me take the another page. First of all, magnesium and hydrochloric acid are reacting together. So first of all, write the equation. When magnesium is reacting with hydrochloric acid, wait. I'm doing right, but let me write the question here. Okay. And this is basically question number 13. So first step is basically when magnesium is reacting with hydrochloric acid, it is converting into magnesium chloride and hydrogen gas. Now in the second step, get the number of moles of magnesium. So it's basically 1.7 divided by AR of magnesium, and AR of magnesium is 24.3. So moles of magnesium is going to be 0.06996 moles. Okay. Let's talk about the moles of HCl. So we have volume, which is 50.0. We have concentration, which is 2.2 divided by 1000. So it's going to be how much? 0.11 mole. Okay. Now, according to the equation, 2 moles of HCl is reacting with 1 mole of magnesium. So if 0.11 mole of HCl is reacting with how much moles of magnesium? So moles of magnesium is going to be 0.11 divided by 2 is going to be 0.055 moles. Whereas how much moles we have? 0.06, which means this moles are greater than this moles. So the magnesium is in excess, well, HCl has to be the limiting reactant. Okay. Whew. Now we really need to find out the volume of gas produced. So according to the equation, we have 2:1 ratio. Now HCl and hydrogen has 2:1 ratio. If HCl has 0.11 moles, how much moles of hydrogen we have? So moles of hydrogen is going to be 0.055 moles. Now I can apply P equals to nRT. So V equals to nRT upon P. N is 0.055. R is 8.31, which is a fixed value. Temperature is basically 303 Kelvin. And pressure is given already in Pascal. So we don't need to go for the conversion, which is 1,110,400. So volume is going to be 1.25 into 10 to the power minus 3 meter cube. All right. So converted into dm cube. Oh, so volume is going to be how much? Basically 1 meter cube equals to 10 to the power 3 dm cube. So if you have 1.25 into 10 to the power minus 3, how much volume we have? Let me check. 1.25 exponent minus 3 into exponent 3. So it's basically 1.25 dm cube. So 1.25 dm cube, which is nearest to 1.3. So my answer is going to be Na. Okay. Let me give you another shortcut. If 0.055 moles of magnesium we have, if we have 0.055 moles of hydrogen, let's multiply this volume, let's multiply this value by 24 dm cube. Let me give you straightforward. 0.055 times 24, it's going to be exactly 1.32. So instead of doing this working, because it's given in the question, so I have to take it into account, but I believe just skip this, multiply moles with volume at RTP, which is 24 dm cube, you will get exactly 1.32. So you will get an A. Okay. So anyhow, you will get an A. That's the logical, explanation with this question, because these values are given in the question, which means we have to consider it in our calculation. Otherwise, you can do a small shortcut that multiply this number of moles with the volume, molar volume at RTP. So we'll get your answer 1.32. Okay, I hope it makes sense to you. That's a very, very long calculation. My goodness. Anyhow, question number 14. Chlorine dioxide, ClO2, reacts with aqueous NaOH to produce water and a mixture of two sodium salt, NaClO2 and NaClO3. ClO2 is basically this one. Oh, my bad. It is reacting with NaOH, converting into NaClO2, NaClO3, and obviously water. Okay. So how many sodiums we have here? 2. So put 2 here. How many chlorines here? 2. Put 2 here. So sodium is balanced, chlorine is balanced. Let's talk about hydrogen. How many hydrogen atoms here? 2. Hydrogen 2, balanced. Let's talk about oxygen. 2 times 2, 4. 4 plus 2, 6. 3 times 2, 3 plus 2, 6. 6. Oh, sorry, 3 plus 2, 5. 5 plus 1, 6. So it's a balanced chemical equation. By the way, according to this balanced chemical equation, both this has 1:1 the ratio. Therefore, C is going to be the right answer, because he's asking the molar ratio of these two product mixture. That's an easy question. After such a long calculation, I think it's an easy question. Okay. Okay. Question number 15, the temperature of the sample of an inert gas is increased. So when temperature increases, kinetic energy increases, collision frequency increases, rate of reaction increases. What effect does this have on the number of molecules with the most probable energy, and how's the number of molecules with higher energy? Okay, that's Boltzmann distribution curve. According to Boltzmann distribution curve, which I've told you in the class, on y-axis we have number of particles. On axis we have kinetic energy or just energy. Okay, this is the most probable energy. At low temperature. Now we are increasing the temperature, right? So curve, one more thing, one more thing. This is the molecules which have enough energy for the reaction, right? Now at high temperature, the curve flattens and maximum shifts to the right hand side like this. So this must be the fraction now. And obviously fraction increases at high temperature, and this is going to be the most probable energy at high temperature. So at low temperature, probable energy is high, whereas at high temperature, probable energy is low. Probable energy is low at high temperature. Obviously, C and D is incorrect. Probable energy decreases, okay? And number of molecules with higher energy, obviously this entire fraction of molecule has higher energy than the previous. This entire fraction has more energy than the previous one. That is, so it has more energy, which means this one and this one. So right answer is going to be B. Okay, because at high temperature, the fraction of the number of molecules increases, which means rate of reaction increases. So, question number 16. For which compound is there the greatest percentage loss of mass on a strong heat? Okay, greatest percentage mass. Loss in mass belongs to the loss of gas. Okay. So for option A, calcium carbonate, when heated, it will turn to calcium oxide and carbon dioxide. Percentage loss, we need to find out. So mass of carbon dioxide is 44. MR of calcium carbonate is 100.1 into 100, because we really need to find out the percentage. So percentage is basically 44%, right? Let's talk about B. Let's talk about C, because first we need to find magnesium carbonate is decomposed on heating, converting into magnesium oxide and carbon dioxide. Again, we need to consider carbon dioxide for percentage loss. Carbon dioxide has an MR of 44. Magnesium carbonate has an MR of what? Now we need to calculate the MR of magnesium nitrate. Sorry, magnesium carbonate. So magnesium carbonate is basically 84. I think so. Magnesium is 24.3 plus 1, 24 plus 12 plus 16 times 3 is going to be 84. 84 into 100. So 44 into 100 divided by 84 is going to be 2%. That's a very tough question because we need to attempt each and every option here. Let's talk about B. Oh my goodness, we need to make the equation first. This is calcium nitrate. It is converting into calcium oxide, nitrogen dioxide, and oxygen. Now we need to find out the mole of this entire gases. That's a lot of calculation, guys. A lot of calculation. The MR of NO2 is 46. Since we have 2 moles into 2 is going to be 46 into 2 is going to be 92. Mole of oxygen is 32. Since we have half mole into 0.5 is going to be 16. So 92 plus 16 is going to be 108. So 108 is basically the lost mass. Okay. Percentage loss, find out. So 108 is the mass, loss in mass, divided by MR of calcium nitrate, which is 164. 164 you need to calculate at your own. It's not given in the book question. So 108 divided by 164 into 100. It's basically 65.8%. My goodness. I have to calculate option D. So percentage loss in option D is also 108 because 2 moles of NO2 and half mole of oxygen is also formed from this compound. So percentage loss, to find the percentage loss, mass of gases is 108, MR of magnesium nitrate. Let me find out MR of magnesium nitrate. MR of magnesium nitrate is 148 into 100. So it's going to be how much? 73%. Now 73% is the greatest percentage loss in mass, which means D is going to be the right answer. Okay. The solid sodium chloride and sodium iodide both react with concentrated sulfuric acid at room temperature. Now, when sodium chloride is treated with concentrated H2SO4, it is converting into sodium hydrogen sulfate and HCl, which means H2SO4 is a weaker oxidizing agent than chlorine because H2SO4 cannot oxidize chloride into chlorine. Okay, so in this reaction, acting as an acid. Whereas in this scenario, sodium iodide is reacting with H2SO4, converting into sodium hydrogen sulfate and hydrogen iodide. Now this hydrogen iodide is again reacting with H2SO4, converting into H2S plus sulfur plus water plus I2. Okay. So in this, it is acting as an acid. In this reaction, it is acting as an oxidizing agent. So in this scenario, it is acting both as an oxidizing agent as an acid. Okay, that's what we have done in the class. What is the explanation for the difference in the product? Guys, product. Examiner is talking about product. So chloride ions displaces iodine from the solution? Not at all, because chlorine can displace iodide ions. Chloride ions cannot displace. Okay. Next is hydrogen chloride is more volatile than hydrogen iodide. Well, Hi has more electrons, so it has a strong van der Waals forces than HCl, which means this option is also incorrect. Because if hydrogen iodide has more number of electrons as compared to hydrogen chloride, obviously this hydrogen iodide has stronger van der Waals forces or temporary induced dipole forces, which means it has higher boiling point than this one, right? Which is why B is incorrect, because examiner is talking about volatility. Iodide ions are better reducing agent than chloride ions. That's true, because down the group reducing power of halide ions increases according to my lecture. So chloride, bromide, and iodide. The reducing power of halide ions down the trend increases due to the increase in ionic radius. So when ionic radius increases, nucleus to valence electron attraction decreases. So removal of electron becomes easier, oxidation becomes easier. If oxidation becomes easier, then it means iodide ions are better reducing agent than chloride ions. Seems like C is going to be the right answer. Let's talk about last option. Sulfuric acid is able to act as a dehydrating agent with NaI. I've told you clearly that in the first equation it is acting as an acid, whereas in the second equation it is acting as an oxidizing agent. So in these two equations, H2SO4 is not reacting as a dehydrating agent. Technically, H2SO4 or sulfuric acid is acting as a dehydrating agent in organic instead in inorganic, right? So D is incorrect. SiO2 has a melting point of this. This indicates that SiO2 has a giant molecular structure with strong covalent bonds, so it has high melting point. Okay, it reacts with hot concentrated NaOH to form sodium silicate. Okay, so this must be the case we have done in class. Sodium silicate is Na2SiO3 plus H2O. By the way, this is an alkali. Okay, and this is basically an acidic oxide, which means it is an acid-base reaction or acid-alkali reaction. No reaction occurs when SiO2 is added with this. Obviously, it is an acidic oxide. It is also an acid. They cannot react together. What can be deduced from this information? Chemical behavior of SiO2. SiO2 is an acidic oxide. Structure of SiO2, giant molecular. So right answer is going to be C. Okay. Question number 18. Element X has the second largest atomic radius in its period, and an atom of X has 3 occupied electrons shells only. 3 occupied shells only. So if 3 occupied shells, then it means element belongs to period 3 of the periodic table. All right. So first 3 occupied shells means period 3 element belongs to period 3. As it has 3 occupied shells. Okay. The oxide of X is shaken with water. X has the second largest atomic radius in X period. That's a very powerful statement. Let's suppose we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. All right, these are the period 3 elements. The second largest atomic radius. So across the period, atomic radius decreases. Atomic radius decreases, which means chlorine has a smaller atomic radii than sodium. So examiner is saying second largest atomic radius, which means this is the second largest atomic radius. Magnesium, second largest atomic radii in period 3. So if magnesium has an oxide, like magnesium oxide is placed in water, it will give you magnesium hydroxide with a pH value of 9. I've told you that it's a weak alkaline solution with a pH value of 9. We have given this information in chemical periodicity. So I think you should remember this. So magnesium is the second, magnesium is element X because it has the second largest atomic radius. And since it is found in period 3, which means it has 3 occupied shells. So when magnesium is placed in water or is shaken with water, it will give you an alkaline solution of magnesium hydroxide, which is also called milk of magnesia. And milk of magnesia is a weak alkaline solution, which means it has a pH of 9. So C is going to be the right answer. Question 20. Which emission from an internal combustion engine contributes to erosion of marble? Erosion of marble always due to the formation of acid rain. Due to acid rain. Well, unburnt hydrocarbon, when reacted with nitrogen dioxide, it will turn to photochemical smoke, and photochemical smoke is also called PAN, which never contributes to acid rain. So it's D is incorrect. Nitrogen dioxide, yes, contributes acid rain because when it is placed with water, it causes nitrogen dioxide as well as nitric acid. Oh, sorry, nitrous acid and nitric acid, which means C is going to be the right answer because it it is formed through the internal combustion engine, right? Nitrogen never causes acid rain, and it is not the emission product of the internal combustion engine. Carbon monoxide is the emission of internal combustion engine, but it is reacted with oxygen to give you carbon dioxide, which causes global warming mostly, and it is partially soluble in water. So this is also incorrect. Okay. Uh, if we want to compare the solubility of carbon dioxide and nitrogen dioxide, obviously nitrogen dioxide is more soluble than carbon dioxide, which is why nitrogen dioxide undergoes disproportionation reaction with water, and so it will form nitrous acid and nitric acid. Whereas it's going to be converted into carbonic acid, which is a very weak acid as compared to these two. So this contributes more in the acid rain, which is why it can erode marble statues. Marble statues are made up of calcium carbonate, also called limestone. Okay. Question number 21. The diagram shows the melting point of 8 elements with consecutive atomic number. Which element could be sodium? All right, that's an easy question. This has the highest melting point, so it must be silicon. And since all the elements arranged in consecutive atomic number, that indicates if this is silicon, this must be aluminum, this must be magnesium, and this must be sodium. So C is going to be the right answer because examiner is talking about sodium. Okay. So this is group 14, group 13, group 12, sorry, group 2, and then group 1. Okay. So this is going to be the noble gas, and this is going to be the group 1 element. Okay. That's an easy question. Question number 22. The boiling point of bromine, ICl, and IBr are given in the table. Which row explains why the boiling point of ICl is greater than IBr? That's extremely easy. Now, ICl has two different situations. Number one, it has permanent dipole-dipole forces. And because it is a polar molecule, whereas this one has temporary induced dipole-dipole forces or instantaneous dipole-induced dipole forces because it is non-polar, which is why the boiling point of ICl is greater than that of Br, hence proved. So first statement is ICl exhibits permanent dipole-dipole forces. So this is permanent dipole-dipole forces, this is permanent dipole-dipole forces. Okay. So option A and option C is absolutely incorrect. Competition exists between B and D. Let's find out the another option. Why the boiling point of IBr is greater than ICl? Yes. Yes. IBr because bromine is more electronegative element, so it has more polar No, 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 no. IBR has more number of electrons, so it has greater instantaneous dipole induced dipole forces. It has less number of electrons, so it has weaker instantaneous dipole induced dipole forces. So IBR has stronger instantaneous dipole induced dipole forces. So right answer is going to be obviously B. Okay. Question number 22. And after that, let's talk about question 23. A solution contain both magnesium ion and strontium ion at the same concentration. Okay. Both these ions belongs to group 2 of the periodic table because they have same charges. Okay. The solution is divided into two equal portions. Aqueous sodium hydroxide is added dropwise to one portion. Then obviously white precipitates are formed. Dilute sulfuric acid is added dropwise to the other portion. Okay, which row is correct? Precipitate seen first when NaOH is added. I've told you then from magnesium hydroxide to barium hydroxide, solubility increases. We have discussed this trend in the lecture. That means it is less soluble, and obviously it is more soluble in comparison. So precipitates first seen should be of magnesium hydroxide. Okay. Precipitates seen first when H2SO4 is added. So when H2SO4 is added, obviously magnesium sulfate is formed. So according to my lecture, we have magnesium sulfate, calcium sulfate, strontium sulfate, and barium sulfate. And according to my lecture, solubility of group 2 sulfates decreases down the group, which means this is more soluble and this is less soluble. Okay, so more soluble, precipitate seen first, more soluble, and less soluble. Less soluble is this and this. So right answer is going to be B. Question number 24. Okay. The structural isomerism and stereoisomerism should be considered when answering this question. Okay. And stereoisomerism can be optical, can be geometrical. Okay. If a molecule contains two non-identical carbon atoms, four optical isomers exist. How many isomers are there with molecular formula C7H14O? A 5-membered ring. So let me make 5-membered ring. 5-membered ring. must be like this. This is 5-numbered ring. Okay, let me work on it. So 5-numbered ring, I have drawn it already. We have a tertiary group. That means one OH group should be there. And since it must be the tertiary group, so tertiary group is attached to the 3 neighbor carbon atoms. 2 neighbor carbon atoms already there. We need to attach another one. So let's suppose this must be another alkyl group. How many carbon atoms we have? 1, 2, 3, 4, 5, 6. We have 7, which means we need to add one more carbon atom like this. So how many carbon atoms here? 1, 2, 3, 4, 5, 6, 7 carbon atoms. Satisfied? Hydrogens. 3 plus 2, 5, 5, 5, 7, 9, 11, 11 and 2, 13, 13 and 1, 14 and 1 oxygen. So this is satisfied. By the way, this is not going to be the chiral carbon atom. Not chiral. Why? Because this side and this side of the cyclic ring is same, which means it has a symmetrical cyclic. If it has a symmetrical cyclic ring, obviously you will not get any chiral carbon atom in this scenario. No chiral. Okay. Let me do this. We have one OH group, and for tertiary, we need to attach one alkyl group here. How many carbon atoms we have? 1, 2, 3, 4, 5, 6. We have one carbon, and how many hydrogens? 3. So let me put here. So this is going to be your chiral. This is going to be your chiral. We have 2 chiral carbon atoms, so it's going to be 4 isomers. Okay. And by the way, this must be the first carbon, this must be the second, this must be third, fourth, fifth. All right. So it must be 1 and 2. So alkyl groups attached to first and second carbon atom. Okay. This is OH. For tertiary, we need to attach one alkyl group. And let's suppose we attach one more alkyl group on this carbon atom. So this is going to be the first carbon. Wait. This is going to be the first carbon. This is going to be the second carbon, and this is going to be the third carbon. So we have again 2 chiral centers. This one is first, this one is second, because it is not symmetrical. See, we have 2 different situations here, so it is not symmetrical. Similarly, we have 2 different situations here because it is not symmetrical. Okay, so both are unsymmetrical cyclic rings, which means we have chiral carbon atoms. So we have 2 chiral carbon atoms in this scenario, which means we can apply to the power n formula. So we'll get 4 isomers in this case. And in this, we have alkyl group on first and third carbon atom. So in total, how many total stereoisomerism? 4 plus 4, 8 stereoisomerism. This could be the structural isomer with respect to these two, which means in total we have 9 isomers, and therefore C is going to be the right answer. So let's start question number 25. Which reagent will react with pentane 3-ol, give a mixture of stereoisomers? Stereoisomers are of 2 types, either optical or geometrical. Optical or geometrical. Okay. Now pentane 3-ol is this. And when you treat it with potassium dichromate 6, obviously it is a secondary alcohol. It will oxidize with this and will turn to a ketone. this. And this ketone, we don't have any chiral carbon atom because this group and this group is same on both the sides. Now the option B is basically concentrated sulfuric acid. So whenever an alcohol is treated with concentrated sulfuric acid, it undergoes dehydration. And as a result of that, you will get double bond here. Or double bond here. So this is going to be your cis, and this is going to be your trans. So from B, I can get geometrical isomers, which means B is going to be the right answer. Let's talk about C. Ethanoic acid in the presence of little concentrated H2SO4, that means an ester is formed. So pentane 3-ol, it's like this. And when you react with ethanoic acid, so when pentane 3-ol, 1, 2, 3, 4, 5, react with ethanoic acid, you will get an ester. Let me make the structure of an ester. This is oxygen. Then we have C double bond O. Then we have CH3. And we have this and this group. So this is not going to be the chiral carbon atom because this group and this group are same, which means C is also incorrect. And we don't have any double bonded carbon atom, which means this will not give you geometrical isomerism as well, right? So no chiral. Because these are the similar groups on both the sides. Hydrogen chloride undergoes substitution, so obviously OH is being replaced with chloride ions. So there is no as such stereoisomers. Why? Because let me write it. This is OH. When it is treated with HCl, OH has gone, but this group and this group are same, which means it has no chiral carbon atom. This group and this group is same. So I think B is going to be the right answer because through concentrated sulfuric acid, we are getting geometrical and optical, geometrical isomers, that is cis and trans. An organic molecule W contains 3 carbon atoms. It requires 4.5 molecules of oxygen for complete combustion. What could W be? Okay, propane is basically C3H8. When it is treated with oxygen, it is converting into carbon dioxide and water. How many oxygen? 6 plus 4, 10. So I will put 5 here. We need 4.5 molecules of oxygen for complete combustion, which means A is incorrect. Let's talk about propanoic acid. Propanoic acid is C3H7 COOH. Propanic, oh, that's butanic acid. So it's going to be C2H5COOH. If you treat it with carbon dioxide, oxygen, it will turn to carbon dioxide in water. How many carbon atoms here? 2 plus 1, 3. So put 3 here. How many hydrogen atoms? 5 plus 1, 6. Put 3 here. How many oxygen atoms now? 3 plus 3 times 2, 6. 6 plus 3, 9. So 2 already here. So 9 minus 2 becomes 7. So it's going to be 7 upon 2. Again, we are not getting 4.5. So it's B is also incorrect. Propanol has C3H6O. It is reacting with oxygen, converting into carbon dioxide and water. We have 3 carbon and 6 hydrogen. So we have 3 carbon and 6 hydrogen. How many oxygens now? 6 plus 3, 9. We have 1. 9 minus 1 becomes 8. So 4O2. So again, this is going to be incorrect. So if A wrong, B wrong, C wrong, correct answer is going to be D. Let me give you the option or equation. Propane 1-ol, that is C3H8O. If you treat it with oxygen, you will get carbon dioxide and water. So we have 3 carbon, 8 hydrogen. We have 3 carbon and 8 hydrogen. Let's talk about oxygen. 3 times 2, 6. 6 plus 4, 10. We have 1. 10 minus 1, 9. So it's basically 9 upon 2. So that basically 4.5, which requires 4.5 moles of oxygen. All right. Question number 27. Which equation represents a reaction that proceeds through initiation, propagation, and termination? By the way, these 3 steps takes place in free radical substitution reaction of alkane. So this is alkane. Chlorine is reacting in the presence of UV light. Obviously, these 2 products are formed. So A is going to be the right answer because this is an alkyl halide. Alkyl halide always undergoes nucleophilic substitution reaction. Option C is basically C6H12. CnH2n plus 1, 6-12 plus. So this is an alkene. Alkene, when react with steam, it will form an alcohol. So it's basically electrophilic addition reaction. C6H12. The general formula of alkene is CnH2n. Apply C6H2 times 6, C6H12. So it's basically an alkene. An alkene always undergoes electrophilic addition. Now this is an aldehyde, and aldehyde undergoes nucleophilic addition. So nucleophilic addition never undergoes initiation, propagation, and termination. I hope it makes sense to you. Let's talk about question 28. Structural isomerism and stereoisomerism should be considered when answering this question. This question is extremely tricky because it has calculation and it has set of isomeric hydrocarbons, maximum number of isomeric compound in the set. That's very, very tough. Very, very tough. Let me copy this question. Let me copy this question so that we can solve it on the next page, a separate page. Okay. This question is 28. Now, first of all, we have mass of bromine, which means we can find the moles of bromine. So we have mass of bromine. So first of all, moles of bromine. So 0.799 divided by the MR of bromine. And the MR of bromine is MR of bromine 159.8. So it's going to be how much? 0.799 divided by 158.9. 159.8. My bad. 159.8. 0.7. 159.8 is going to be 5 into 10 to the power minus 3 moles. Okay. Since bromine and hydrocarbon has 1:1 ka ratio, so this is hydrocarbon and this is bromine. Both have 1:1 ratio. If you have 5 into 10 to the power minus 3 moles, obviously moles of hydrocarbon is also same, which is 5 times 10 to the power minus 3 moles. We know that the mass of hydrocarbon is given, which means I can find the MR of hydrocarbon. Mass is 0.280 divided by moles, 5 into 10 to the power minus 3. Okay, 0.280 divided by answer is going to be 56. So 56 is the MR of this hydrocarbon. We need to find out the molecular formula of hydrocarbon so that I can find the isomeric hydrocarbons. And for that, examiner has given me percentage by mass of hydrogen. So in the next step, we have carbon, we have hydrogen. Hydrogen is 14.3. So if 100 minus 14.3, it's going to be 85.7% carbon, because it consists of carbon and hydrogen only, as it is a hydrocarbon. Okay, divided by 12, divided by 1, it's going to be 7.14. It's going to be 14.3. Get the simplest ratio by dividing the least value on both the sides. So it's going to be 1. It's going to be 2. So the empirical formula of hydrocarbon is CH2. I know the empirical formula. I know the molecular mass. I can get the molecular formula by using these two values, right? So my point is that CH2 taken N equals to 56, 14N equals to 56, N equals to 4. That means the molecular formula of this hydrocarbon is C4H8. So that's the molecular formula, and by using this, I can find the isomeric hydrocarbons. Now, how many isomeric hydrocarbons? Since it is butene, so first hydrocarbon or first structure has to be like this. First isomer, I mean but1ene. Then we have but2ene, and this but2ene has both cis and trans isomer. That means we have cis but2ene, we have trans but2ene, we have but1ene, and also we have 2-methyl propene. That's what we have done in the class, right? So this is the first isomer, and this is the second isomer. This one is the third, and this one is the fourth. So we have 4 isomers. So C is going to be the right answer. C is going to be the right answer for this. That's a very, very tough question. That's a lot of calculation actually. My goodness, look at the calculation and look at the isomerism. Okay. Which row describes solvent used and type of reaction occurring when bromoethane reacts with NaOH to form ethene? So when alkyl halide undergoes a reaction with NaOH and an alkene is formed, then this reaction is called elimination. So elimination is here, elimination is here. Type of reaction is basically elimination, because whenever alkyl halide undergoes elimination, alkene is formed. Okay, sodium hydroxide is solid at RTP, but obviously in order to use as a solvent, we need to dissolve it in water. So water is going to be the solvent here. So right answer is going to be C. Right? C? No? Oh, my bad, my bad, my bad. According to my lecture, elimination always takes place through ethanolic solution of sodium hydroxide. If sodium hydroxide is a reagent, obviously ethanol is used as a solvent, right? That's an easy question. How can I make a mistake in this sort of question? So you guys have to be very, very alert in such questions, okay? The right answer is going to be an A. Question number 30. Which row describes the type of reaction? Again, type of reaction that occurs when propane 1-ol reacts to form the named carbon-containing products. Propane 1-ol never undergoes addition. Actually, it's a substitution reaction. Okay. So option A is incorrect. When alcohol turned to an alkyl halide, obviously it's going to be the substitution, not addition. Okay, next is carbon monoxide and complete combustion. So it's incorrect. It has to be incomplete combustion, because carbon monoxide is always formed through incomplete combustion. So B is also incorrect. When alcohol is converted into an alkene, then this process is called dehydration, which is right. C is going to be the right answer. Let's talk about D. When alcohol is converted into an aldehyde, obviously it's going to be the oxidation. Examiner is saying reduction, which is incorrect. It must be an oxidation. Okay, so D is also incorrect. C is going to be the right answer. Question 31. Which statement describes what happens when 2-chloro-2-methylpropane is warmed with NaOH? Let me make the structure first for 2-chloro-2-methylpropane. So propane has 3 carbon atoms. We have 2-chloro, which means on the second carbon we have chlorine. We have 2-methyl, which means on the second carbon we have CH3. Now arranged or satisfy with carbon and hydrogen, which means this is tertiary alkyl halide, 3-degree alkyl halide, and 3-degree alkyl halide always undergoes SN1 reaction. And SN1 reaction is always a 2-step reaction. SN1 reaction is a reaction in which tertiary carbocations are formed. And tertiary carbocations are stabilized through positive inductive effect of alkyl group. That means option B is incorrect. That means option A is incorrect, because it is saying secondary halogen alkane, which is, but technically it is tertiary halogen alkane. Okay. Now competition exists between B and C and D. Sorry, this tertiary halogen alkane reacts mostly by SN1 mechanism. That's right. That's right. Tertiary halogen alkane does not react with hydroxide. It does react with an hydroxide ion. It does react with hydroxide ions so that you will get an tertiary alcohol. Okay, so right D is also incorrect, and therefore C is going to be the right answer. Okay, and let me give you the reaction. So when NaOH is used under heat, because examiner is warming the solution, it will turn to a tertiary alcohol, which means hydroxide ions are also involved in the reaction, and therefore D is incorrect. Okay, 32. How many structurally isomeric secondary alcohols? Stick to secondary alcohol. We really don't need tertiary and primary alcohols. Are there with the molecular formula C5H12O. Okay, first of all, CH3, CH, OH, CH2, 1, 2, 3, 4, and 5. This is my first one. Second one is shift OH to this carbon and hydrogen to that carbon atom. So it's going to be CH3, CH2, CHOH, CH2, and CH3. Okay. Shift this alkyl group to that carbon and hydrogen to this carbon atom. CH3, CHOH will remain as it is, then CH, and then CH3, and then CH3. Okay. This is secondary alcohol, by the way. This is secondary alcohol. This is secondary alcohol. This is secondary alcohol. Is there any possibility left? I don't think so. There is another possibility exists now. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, I don't think so. If I'll shift to this carbon and hydrogen to that carbon, obviously it's going to be the tertiary group, right? We need. I think that's the only answer. C is going to be the right answer. Okay. But remember, secondary alcohol. How can I identify the secondary alcohol? OH attached to that carbon has only one hydrogen. Okay. That is the criteria of secondary alcohol. This criteria is the secondary alcohol. Question 33. Which reagent can confirm the presence of a carbonyl group in an organic compound? So, presence of carbonyl group. For this, we can use 2,4-DNPH. Does not distinguish between aldehyde and ketone. Oh, if you cannot distinguish aldehyde and ketone, which means I will use 2,4-DNPH, because this 2,4-DNPH observation is same both for aldehyde and ketone, and so we cannot distinguish whether it's aldehyde or ketone, right? So 2,4-DNPH is a reagent which is used to determine the presence of carbonyl group in an organic compound. Also, this reagent has similar test both in aldehyde and ketone, which means B is going to be the right answer. Okay. Why not A? Why A is incorrect? Because aldehyde can oxidize, ketone cannot. In fact, aldehyde can oxidize. 1 degree alcohol, 2 degree alcohol can also oxidize. Phthalate reagent can react with aldehyde, not with ketone. So By using this reaction, I can distinguish aldehyde and ketone easily. Lithium aluminum hydride undergoes reduction both with aldehyde and ketone. Since we will not get any sort of observation, so we can't really use this reagent to distinguish between aldehyde and ketone, because we will not get any color observation in this regard. Okay, so C is incorrect, D is incorrect, and therefore B is going to be the right answer. I hope it makes sense to you. One more thing, when Fehling reagent reacts with aldehyde, obviously you will get brick red precipitates of copper monoxide. This observation is not gonna come in ketone. Question 34. Which compound gives a positive test with alkaline aqueous iodine? Well, alkaline aqueous iodine gives positive test when we have CH3, CO group present, okay, and does not show optical isomerism. That means no chiral carbon atom. So my answer is A straight away, because in this compound there is no chiral carbon. Okay, and also CH3 CO group is present in this compound. Okay, this is chiral, which is why it is incorrect. This is chiral, which is why it is incorrect. No CH3 CO group or no CH3 CH OH group exist. And no chiral carbon. Since last compound in option D has no chiral carbon atom, has no CH3CO group, has no CH3CHOH group, which means it cannot give you iodoform test, which is why D is also incorrect. Okay. Question 35. Two samples of compound X were treated separately with different reagents which were added in excess. Okay, the product of these two reactions are shown. Look, this is secondary alcohol. It will remain as it is in reaction 1. This is ketone. It will remain as it is in reaction 1. This is an aldehyde. It is converting into carboxylic acid, which means in reaction 1, we are oxidizing aldehydic functional group into carboxylic acid. And for that, we need a reducer. We need an oxidizing agent. And since only one step oxidation takes place, that is from aldehyde to carboxylic acid, which means we need weak oxidizing agent. Okay. Now in the second reaction, see, this secondary alcohol will remain as it is, but this ketone will turn to a secondary alcohol. Similarly, this aldehyde will turn to primary alcohol, which means these two functional groups is converting into these two relatively secondary alcohol and primary alcohol, which means reduction takes place. So which means we need a reducing agent in this situation. So in reaction 2, we need a reducing agent, and obviously the reducing agent is here and here, and we need a weak oxidizing agent. Well, sodium dichromate is a strong oxidizing agent. It can oxidize secondary alcohol into ketone. Since it is not converting secondary alcohol into ketone, which means I cannot use this one. And Tollens reagent do react with aldehydic functional group, because Tollens is a weak oxidizing agent according to my lecture, which means Tollens reagent is the right answer. So therefore D is going to be the right answer. Okay. Question 36. Which method could produce butanoic acid? Butanoic acid. When you oxidize this compound, obviously this CH2OH will turn to carboxylic acid, and so you will get propanoic acid. Examiner is asking butanoic acid, which means D is incorrect. So when you use acid hydrolysis, obviously it's going to be CH3, CH2, 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 and this CN will turn to CWH. So it's not butanoic acid. In fact, it's pentanoic acid. So again, it is incorrect. Now, competition exists between A and C. Let's talk about first C. C is basically an ester, CH3, CH2, CO, O, CH2, CH3. I've told you, break this carbon-oxygen bond. This group comes from acidic part, comes from acid. So it's going to be propanoic acid. And this part of ester is going to come from alcohol. So it's going to be 1, 2, 3, 3, 3. My bad. Okay, no problem at all. No problem at all. CH2 and then CH3. CH3, CH2, CH2. Oh, hold on. CH3, CH2, CO. Okay. So this must be propanol. Okay. Now by using these two reagents, this ester is formed, which means we need butanoic acid. Over here, we are getting propanoic acid. Again, this is incorrect. So if B, C, D wrong, correct answer is in A. Why A is correct? Let me show you working. CH3, CH2, CH2, COO negative plus H positive. Why H positive? Because it is an acid-base reaction. So this is basically your conjugate base. And this is basically your acid. Hence, it is an acid-base reaction. It is converting into CH3, CH2, CH2. Hold on. I'm running out of space. CH2, and then COOH, and that's your butanoic acid. Okay. And how about sodium? Sodium will remain present in the solution, all right, because it is a weak conjugate acid, so it will not have any effect on the reaction. So is going to be the right answer. Question number 37. Which ester may be hydrolyzed to produce two products, one of which may be reduced to the other? Okay. The toughest one, I must say. For reduction, I need the reducing agent. So it must be lithium, aluminum, hydride, and dry ether. Okay. And obviously, in order to reduce that particular product, I need reflux condition as well, or heat under reflux. Okay. We need two products. And these two products are obtained through hydrolysis, right? So let's talk about option A first. This is CH3, CH2, COO CH3. So this must be the acidic part, and this must be the alcohol part. So you will get what from here? You will get propanic acid, and you will get methanol. So we have 3 carbon atom here, we have 1 carbon atom here. Which means so if I'll reduce this compound, it will turn to propanol, which is not in propanol, but it is methanol. So I think A is incorrect. Let's talk about B. My goodness, this question has a lot of working. CH3, CH, CH3, CO, O, CH2, CH, CH3, and CH3. I'll get 2 different products from here after hydrolysis. This must be the acidic part, and this must be the alcohol part. So this is CH3, CH, CH3, CWH, plus alcohol part is going to be CH3, CH, CH3, and then CH2OH. Now we have carboxylic acid. So if I reduce it in the presence of lithium aluminum hydride in dry ether under reflux, it will turn to, under reduction, it will turn to CH3, CH, CH3, and then CH2OH. Now look at these 2 structures. Look at these 2 structures. They are same. So right answer is going to be B. Okay. Okay, so if you reduce this product, it will turn to this one. Question 38. 2 compounds X and Y are mixed and little concentrated H2SO4 is added. That means we are forming ester. So it's formation of ester. And ester formation always takes place when carboxylic acid and alcohol react together. So we really need to find out by using this structure of ester that what kind of a alcohol and carboxylic acid are used during the reaction. Element Z is found in resulting mixture of products. Which 2 compounds could X and Y? Obviously, I've told you, whenever hydrolysis of ester takes place, break carbon single bond oxygen, break carbon single bond oxygen. Okay. So this must be ethanoic acid, and this must be ethanoic acid as well, because we have 2 carbon atoms. So this is ethanoic acid, CH3, COOH, and this is also ethanoic acid. So X is going to be ethanoic acid, which means option A and B incorrect. How about this one? This is your X, this is your X. Let's talk about the Y one. Y, compound Y. Okay, this product, this oxygen, double bonded oxygen, this is OH, and this is OH. Okay, this structure. This entire structure is here. So basically, this is your alcohol. This is your Y. Now read the structure very carefully. This is CH3, CH2, then CO2, CH3, CH2, and then CO2. Then we have CH. Wait. CH3, CH2, CH3, CH2. Okay. Then CO, then O. Okay. Makes sense. This is CH3, this is CH2, this is CO2, right? And this is CH2. CH3, CH2, CO2, and this is H2. This is CH, this is CH. It has OH, it has OH. This is CH2OH, this is CH2OH, which means this structure is Y. The right answer is going to be C. That's a bit tricky, all right? That's not an easy task because most of the students can break this bond as well. So if you break this bond, obviously you will not receive any sort of correct answer from here, which means this group needs to stick with this remaining structure. Question number 39. Oh my goodness. The diagram shows the section of a polymer molecule. Oh my goodness, this is addition polymer. First of all, this is addition polymer. And in addition polymer, always form through alkenes. And alkenes means one double bond must be present between carbon atom. So if one double bond must be present between carbon atom, obviously after the polymerization, this double bond is going to be saturated, right? But in this polymer, we have one double bond, which means in monomer, we have two double bonds. So in polymer, we have one double bond. So in polymer or in monomer, we must have two double bonds. So let me check in which option we have two double bonds. This is going to be incorrect because we have only one. This is incorrect, we have only one. This is incorrect, we have only one. But this is correct because we have two double bond. So how can I make this structure? Let me show you. Let me show you. This is CH2, double bond CH, double bond CH2. Let me write another monomer, CH2, double bond CH, double bond CH2. So according to my lecture, this bond shifts between these two carbon atoms. This bond shifts between these two. This bond shifts between these two. This bond shifts between these two. जो next monomer होगा उसका bond यहाँ पर shift हो रहा होगा. So let me write the structure. CH2, ये bond continuation. Then we have CH. Then we have double bond after shifting. Then we have CH2. Then we have CH2. Then we have CH, double bond, CH. My goodness, that's a lot of things. Okay. CH2, CH, double bond CH, CH2, again CH2, and CH, double bond CH, and then CH2, and then continuation. So this is the structure. This is CH2 here, CH double bond CH here, CH2 here, CH2 here, CH double bond CH here, CH2 here. This is bond continuation here. This is bond continuation here. Okay, I hope it makes sense to you. Again, this question is a bit tricky. Let's move on to the last question. Oh my goodness. There are two naturally occurring isotopes of bromine. Naturally occurring isotopes of bromine. How many isotopes of bromine? Bromine has two different isotopes. The first one is 79. And the second one is 81. Okay. It has 44 neutrons. The other isotope has 46 neutrons. Ignoring fragments, how many peaks are there in mass spectrum of tribromomethane? Okay. How many peaks? So let me make the structure. This is bromine. This is bromine. This is H. This is another bromine. Okay. Let me work on it. According to permutation combination, the first possibility is that all the bromine atoms or bromine isotopes belongs to 79. Okay, so let me find the mass. 79 times 3 plus 12 plus 1 is going to be 250. So MR of this is 250. The second permutation combination shows that all bromine atoms are 81. So 81 times 3 plus 12 plus 1 is going to be 256. Okay. A third possibility is both these bromine are 79 and this one is 81. Let me get the MR of this situation. So we have 79 times 2 plus 81 plus 12 plus 1 is going to be 252. Now in the next permutation combination, is it possible that both these bromine are 81 and this bromine is 79? So 81 times 2 plus 1 plus 12 plus 79 is going to be 254. Now the next possibility is both these bromines are 79 and this one is 81. So we have the same situation, 79 and 81. So its MR it will remain same, which is 52, right? 252 in fact. So we have 279 and 1 bromine. Same here, 279 and 1 bromine. So MR is going to be 252, same. So this is the first possibility of MR. This is the second possibility of MR. This is the third possibility of MR. This is the fourth one. This is the fifth one. And these two are similar. So I'll take as one value. So how many peaks altogether in this scenario? 1, 2, 3, and this one is 4. 4 peaks only. So C is going to be the right answer. Okay. Thank you very much, guys.